Roads play an important role in our everyday lives. As engineers, we would like to design our roads to have excellent strength. However, the other factor that should go along with this is permeability. Let us find out the answer to this question. What will happen if permeability will not be considered? Flooding, pavement deterioration, and road failure. This is why there has been an interest in studying the permeability characteristics of road embankment. Fly ash and bottom ash are two common coal byproducts. Fly ash can substitute fines, while bottom ash can be used as fine aggregates. With these materials regarded as waste, and with the emerging disposal costs, we have come up with a solution through studying the permeability characteristics of road-based materials blended with fly ash and bottom ash. In this study, the researchers follow the ASTM standards in order to determine the index properties of each sample. For the highlight of this study, which is permeability, the researchers followed ASTM 5856 for the vertical permeability. Another thing about permeability is that when it goes through the said surface layers such as concrete or asphalt, it does not only permeate downward but permeates in the horizontal direction. But since there are no ASTM standards for this had led the researchers to design the horizontal permeameter. The horizontal permeameter. The permeameter was designed just like the vertical permeameter. It's made out of acrylic glass for good interior visibility, has its own outlet for drainage, and top cover for confining. It also has a vacuum tap to de-air the sample before testing. It has numerous bolts and of course nuts to seal the sample when saturating. Of course, there is no saturation when there is no water. To deliver the water, we had a 1.8 meter long tube to make water flow into the sample, also designed to handle a hydraulic gradient of 5 which is fixed in this study. First, mix the sample thoroughly with its corresponding water content. Put grease at the walls of the box to avoid sidewall leakage. Then weigh the empty permeameter. Place the sample by layers at its corresponding number of tamps to reach the desired relative compaction. Collect a small portion and weigh so as to determine the sample's actual degree of saturation. Then weigh the mass of the saturated soil. Leave it for 24 hours to fully saturate. Now, the sample is ready to be tested. First, remove air voids using the tap. Then fill the pipe at its corresponding hydraulic gradient. Using a stopwatch, measure the time lapse for the water to drop at the designated gradient. Get the actual temperature and apply the necessary temperature correction factor. Record the gathered data and compute the coefficient of permeability. Here are the index properties of the controlled samples used in the study. Fly ash happened to be the lightest and most porous sample, while the conventional road-based material is the most dense. For the blended samples, as the amount of bottom ash increases, the lighter it is and more water it could hold. In the vertical permeability test for the controlled samples, bottom ash incurred the highest permeability due to its porous characteristics, while fly ash had the lowest due to its cementitious property. So here is the graph for the blended samples at permeability with respect to void ratio. As shown, the higher the bottom ash content, the higher the permeability is. This graph had then made up these empirical formulas. With these empirical formulas, a highway engineer could easily determine the permeability by just substituting either void ratio or relative compaction, and determining the vertical permeability even when both bottom ash content and void ratio are not ideal. Here are the results of the horizontal permeability. For the conventional road-based material as shown in the graph, permeability decreases as the relative compaction increases. Similar trend was produced for bottom ash. Compared to bottom ash, conventional road-based material incurred higher coefficient of permeability primarily because of its flat particle shapes and it has more angular surface that gave more space for the water to flow through. Compared to the results of the vertical permeability test, both conventional road-based material and bottom ash incurred higher horizontal permeability due to the anisotropy characteristic of all samples.
All has been said and done, but it all comes down to what the study can contribute. For engineers, they could easily obtain permeability by just substituting the actual bottom ash content, void ratio, and relative compaction to the derived empirical formulas. In addition, to incorporate the horizontal permeability for future road-based constructions. For the society, utilizing the vast amounts of coal-combusted materials will reduce waste and save Mother Nature. As you can see, we are not only built to build, but geared towards sustainability.